In this section, we'll be talking about slopes and tangent lines. Let's begin by talking about slopes. A slope of a line indicates the rate at which a line rises or falls. The slope is the same at every point on the line. For graphs other than lines, the rate at which the graph rises or falls changes from point to point. So when I'm looking at this graph right here, I see 4 points identified: x1, y1, x2, y2, x3, y3, and x4, y4. For simplicity, I'm just going to call this point 1, point 2, point 3, and point 4. Point 1 is rising, so is point 2. But point 1 is rising much faster than point 2 is. As you can see, point 2 is starting to level off a little bit, and then by the time we get to point 3, it's completely horizontal. Point 4 is now we've tipped the scale and we're starting to fall. So now we're going downward. To determine the rate at which a graph rises or falls at a single point, you need to find the slope of the tangent line at that point. So let's take a look at these 3 examples here. I've got kind of this S-looking shape, and this tangent line is a line that's just going to hit at one point on my graph here, and that is going to tell me the slope of that graph at that single point. Same thing here. I'm kind of swooping down, and at that one point, I'm going to make a line, and the slope of that line is going to be the slope of the graph at that one point. Same thing for this parabola. Now, one way to do this is to make your line and then try to eyeball kind of what the slope is. So if I take a parabola like so, this is f of x equals x squared, and I look at the point 1, 1. I'm going to make a line that goes through that one point and just that one point. And then on that line, I'm going to try and pick another point that kind of fits into my graph. So for example, I've got a point right here that's about 2, 3. Well, that point is 2 units up and 1 unit to the right of the point that's actually on my graph. So 2 over 1 would be a slope of 2. But that's just kind of me using my eyes and trying to figure out my best guess. A more systematic approach would be to use a secant line. A secant line uses 2 points on the graph, and it finds the line through those 2 points and then the slope for that line. Now, what we'll find down here, though, is this point, the closer I have it to my original point, the closer it will be to the true tangent line. Remember, the tangent line only goes through a single point. The secant line goes through 2 of these points. So this second point is going to be h units away. And if the second point is h units away, then the function for the second point would be f of x plus h, if the first point is just my x and then f of x. So to find the slope between these 2 points, I refer to my slope formula, the change in y over the change in x. The change in y would be this height, the difference between them. That would be f of x plus h, because remember, this is now x plus h units away to get to my second point, minus f of x. Now, my change in going from left to right, okay, is going to be just h, because this second point is going to be h units to the right, we'll say. So here, I've got f of x plus h minus f of x. They're pretty far apart. And as it gets closer and closer and closer, I see that the approximation for this slope becomes more like the tangent line. So what does that mean in terms of definition of a slope then, specifically using limits? Well, What that's saying then is the slope m of the graph of f at the point x f of x is equal to the slope of its tangent line at x f of x and is given by the following. M, the slope, is going to be equal to the limit as h approaches 0 of f of x plus h minus f of x over h. What that means is as the distance between those 2 points gets closer and closer to 0, it's going to approach the slope. Let's try this out. Let's find the slope of the graph of f of x equals x squared at the point -2, 4. Now remember, this -2, 4 is my x and y, or I'll say x and f of x. So I'm going to use this. M equals the limit as h approaches 0 of f of x plus h minus f of x over h. Okay, so this will be the limit as h approaches 0 of f of x plus h would be f of x is -2, so -2 plus h minus f of x, so f of -2, and this is all over h. So what does this mean? F of -2 plus h. If my function is x squared, then f of -2 plus h is going to be -2 plus h squared. Let's do that over here. So I'll have -2 plus h squared, so it's going to multiply to itself. So -2 times -2 will be 4. Here I'll have -2h, and then another -2h, and then plus h squared. Let's put this all together. That's going to be h squared minus 4h plus 4. This is f of -2 plus h. So I'll say this is equal to the limit as h approaches 0 of h squared minus 4h plus 4. This is this first part right here. So that'll be this first part right here, minus f of -2. Now what I could do is say f of x is x squared. So f of -2 means -2 squared. And then solve that or evaluate that here. -2 squared would be 4. Now that's fine for something kind of as basic as just x squared. But if I've got a really complicated function, I could just look at this point. This point is x f of x. When I plug in x, I get back f of x. That's 4. F of -2 is 4. And this is all over h. All right, let's see. I've got h squared minus 4h plus 4, and then a minus 4. 4 minus 4, those will subtract out. So I've got the limit as h approaches 0 of h squared minus 4h all over h. And I can factor this. I can pull an h out to the front here. So this will be the limit as h approaches 0 of h. So pulling out an h means dividing both of these by that. I'll have h squared divided by h is h minus 4h divided by h will be 4 over h. The goal here is to be able to divide out this h, which I can do now. The limit as h approaches 0 of h minus 4. This is going to be equal to Well, now I'm ready to put 0 in. This will be 0 minus 4 equals negative 4. So the slope of this function is equal to negative 4 at that point. But that's just for that one point. If I looked at a different point, say x equals negative 3, x equals positive 5, all of those are going to have a different slope, because as this function changes, as this curves around and moves, the slope is going to be different at each of those different points. What if I could find a function, a separate function, where I could just plug something in and find the slope at any point x? Well, what we've defined here is called the derivative of a function. If I were to use the limit process from earlier for any point x rather than a specific point, this would derive another function. This function is called the derivative of the function. I denote this f, and then I've got a little apostrophe here of x. I read that as f prime of x. And so the definition is, this should look pretty familiar. The derivative of f at x is given by f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. This is assuming that this limit exists. The derivative function is a formula for the slope of the tangent line to the graph of f at any point. So this is a really powerful tool, and we can use this very quickly, much more quickly than we could just finding the slope at, a bunch of different points. We just find this one function and then we can plug things into it. Let's do an example. Find the derivative of f of x equals 3x squared minus 2x. So let's set this up. F prime of x, my derivative, is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. So this will be equal to the limit as h approaches 0 of f of x plus h. So this will be f of the f of x plus h. So I actually want to go back here and say this will be 3 times, instead of x, x plus h squared minus 2 x plus h. So I'm taking the function and I'm plugging in x plus h where I have x. So this is that first part. Okay, that's this part right here. Then I want to subtract f of x. That's the original function. So I want to subtract 3x squared minus 2x is the original function. And this is all over h. Let's see what we have. This is equal to the limit as h approaches 0 of 3 times x plus h. I'm going to do a little box over here for that. So x plus h squared, so times itself, x plus h. I'll have x squared plus xh plus xh here, and then plus h squared. So this will be 3 times x squared plus 2xh plus h squared. And I'm still subtracting 2 times x plus h and then subtracting here 3x squared minus 2x. This is all over h. Now it's time to distribute everything. So distributing this 3 here, I'll have this is the limit as h approaches 0 of 3x squared plus 6xh plus 3h squared. Okay, what about here? Minus 2x minus 2h. Then lastly, minus 3x squared plus 2x all over h. Let's see if we can clean this up a bit. I've got, let's see, first I notice a negative 2x here and then a positive 2x. These will subtract out. Is there anything else here? I've got 3x squared and then minus 3x squared later on. So these, if I combine like terms, those will subtract out. Okay, so I'm left with the limit as h approaches 0 of 6xh plus 3h squared minus 2h all over an h. And what I can do is I see in the numerator all 3 terms that are left have an h. So I'm going to pull this h out to the front. This is the limit as h approaches 0 of pulling that h to the front and dividing each term by that h will be 6x plus 3h minus 2 over an h on the bottom. Remember, this whole goal is to be able to divide out this h. And then with what you have left over, go ahead and take your limit. So this will be the limit as h approaches 0 of 6x plus 3h minus 2. This will be 6x plus 3 times 0, because I have to plug in for h here, and then minus 2. Well, 3 times 0 is just going to be 0, which tells me f prime of x, my derivative, is going to be 6x minus 2. With this function, with this derivative, what I can do is plug in any value for x. I can plug in any value for x, and that'll get me the slope at that x value of my original function. This is an extremely powerful tool. It's going to be used throughout the rest of our course here, PreCalculus, as well as much of the different levels of calculus from this point on.